I'm going to do an experiment using an ultracapacitor, where I'll be comparing the ultracapacitor to a regular D-sized battery. The two are about the same size, as you can see. They're about the same weight. This one is about 70 grams, this one is about 55 grams. You can note though that the battery has a lot more energy in it than the ultracapacitor at 9.5 kilojoules versus 1.26 kilojoules. I wanted to test the capability of the two a little bit more interestingly than just using current meter and a stopwatch, so I decided to make an electromagnet. Using some magnetic circuits, I determined that the U-shape is the better shape, and that the limit, if you were to reach 1 Tesla, would be to lift over 100 pounds. Obviously we will get nowhere near that in this experiment, but I created this by cutting off the bottom half of a transformer and smoothing the edge so that you have a good contact surface, and I removed the two windings that were here and put a single winding on here. So this electromagnet is powered by, or it's connected to a switch which is then connected to either the ultracapacitor or the battery here. So the ultracapacitor is charged by a modified mobile phone type charger. I had to put a resistor in series with the charging circuit so that you wouldn't overload the charger during charging. So it takes about 15 minutes to get this fully charged. But potentially this capacitor could be charged in a few seconds if you had a big enough power supply. So I'll do the first test here using the battery. So I created another rig here to measure the strength of the magnet, and to trial and error I determined about the strength of it, what it could support. So we'll energize this, and this is about 2.5 pounds, and it's which the magnets are supporting. Okay, so then we give the supercapacitor, ultracapacitor a test. So I will start like this. Okay, and then a similar rig here. Initially I think I underestimated how much this could carry, because this has become really heavy to hold with only your fingers. So this is more limited by the ability to lift this than the magnet itself. So we'll try this. So let's give it a shot here. Lift. So this is about 20 pounds. I think the true capability is probably around 30 somewhere, but it becomes pretty much impossible to lift if you don't really have a handle on this to hold. So to summarize, even though there's a lot more energy in the battery, the ultracapacitor can support a lot more weight for a short period of time. That has to do with the internal resistance of the device. The ultracapacitor has a much lower internal resistance, which allows it to supply a large amount of current very quickly, whereas if you try that with a battery, it essentially collapses to zero. I did a quick test, and I was in short circuit mode. I was able to get about 5 amps out of this, whereas the ultracapacitor, theoretically, I couldn't measure this kind of magnitude, but it would supply about 845 amps.